Hello, my name is Adam, and I am going to discuss the effect of polymer additives on the sedimentation of granular beads. The reason why I've done this experiment is because I wanted to show how sedimentation can apply and impact the real world and environment. And how when water travels through pipes, the concentration of the particles is reduced. I set up this experiment using a camera on the left, as you see in the slide, and I used an LED light over to the right. And I used a glass chamber that was full of fluids. During the experiment, I had the fluid inside the chamber. And I also transferred the same fluid into a pipette, and which also included some particles. As I used a pipette to drop the particles into the fluid, the water, you can see the sedimentation spread out as it went down vertically. When we used the video, we were measuring the particles, particle sedimentation. We repeated this experiment several times. We are trying to measure the clusters while they were falling vertically, forming the sediment. Now we look at the y-axis, or the vertical position, and we look at the velocity. The average velocity was 17.75 millimeters per second. Also, we measured the size of the particles as they flowed through the water and went vertically down to the bottom, forming sediment. We wanted to show how the particles spread out. And as they fell down vertically, they became larger. It was very interesting because most of the clusters really started at the same size. And we really wanted to make sure the clusters were similar to each other. All of them are roughly 3 millimeters to 10 millimeters at 0.4 seconds. And that was, then the max millimeters was 22 millimeters. It was 1.4 seconds. So it showed that they did spread out more because of the cylinder shape size, or the chamber size. Also, we decided to investigate the polymers to see what their impact was on sedimentation. And the molecules themselves, there was 20 million Daltons for weight. And then the viscosity, we had 20 millipascals. And that was at room temperature. The density was 97.97 kilograms per liter. As you can see in the horizontal slope, it's a straight line. However, vertically, you'll see a variety of placement for the particulates. We started out with different sizes of clusters, but as you saw in the video, the clusters didn't fully spread out, or they didn't break up. However, they were stretched down. So it showed the impact of the polymer of what it had on that sedimentation of the particles involved. We work with high polymer density, and the clusters all kind of got entangled in their groups. When we use the pipette to drop some more in the cylinder, it mixed with the polymers, and then the gravity pulled them down vertically. However, the polymers tried to hold them together, but that didn't work. They still stretched out. So the sediment was actually slower than one particle in terms of velocity. And I want to thank everyone for helping me with this project.